Our project for our fourth semester control applications class was to design and build an automated gumball machine which uses a Cognex vision system to scan colors of gumballs and determine whether or not it's the correct color gumball, which the user can select using a HMI, a human machine interface, on the front panel. So what we're going to do is start getting into some of the specifics of the different components that we used and how we ended up putting it together. For our HMI, we ended up using a PanelView Plus 1000, which uses FactoryTalk Studio as its software, which we were able to actually program and create a front panel that the user could use to select the gumball colors. The screen that you're looking at right here is our main screen, which has the 4 colors that we had it programmed for the user to be able to select. This particular panel view that we used actually runs off 120 volts AC and is connected up to our PLC using an Ethernet cable. In addition to our main screen, which lets the user pick the gumball color that they want to come down, we also added a manual actuation screen, which was more for the purpose of troubleshooting and just being able to test out some stuff, but it allows the user to manually actuate all 4 cylinders in our gumball machine, as well as manually spin the servo whenever that button is pressed.
This is our DC power supply. It is a Rhino. It provides 3.75 amps of DC current and 24 to 28 volts DC. It is ran off 120 volts AC. It powers our Cognex camera as well as our PLC. This is our AC distribution terminal. It starts off with a 10 amp circuit breaker. And then we also have our HMI as well as our drive separately fused. That's 120 volts AC. This is the PLC that we used. It is a Compact Logix L24ER QB1B. It has 16 ins and 16 outs. Both are 24 volts. We used RS Logix 5000 to program it. It controls things like our solenoids, as well as our Cognex and the drive.
For our project, we ended up using pneumatic air pressure to actuate all of our cylinders. This is just a picture of our regulator, which we have been running at around 50 to 60 psi, which it needs at least a minimum of 40 psi since the valves operate on pilot pressure. This is our valve bank. We ended up using 4 Festo air valves, and again we had the solenoids hooked up to our output card. They run on 24 volts DC and they operate our 4 cylinders. We actually have several flow controls on our machine. This is just a close-up of our feed throat block, and it's just showing the small inline valves that we use to control the air pressure going to our cylinder.
This is our diverter. It's 2 pieces of PVC that we cut and stuck together. There is a diverter flap inside of it that will be controlled by the cylinder, depending on if the ball is the correct ball that you chose or if it's the wrong ball. The logic inside of our system will either extend the cylinder or retract it and control which chute of the diverter the ball goes down. This is our return cylinder. If the ball was not the ball that you chose, it'll be diverted down to our return chute, at which point the return cylinder will extend at a rapid pace and shoot the ball back up the return chute into the hopper. Here we have our servo drive. It's a Parker TQ10X drive. The way we have it set up is that we wired the input to a relay coil, so that way we can control the coil with one of the outputs on our PLC, and we can use our logic in our PLC to control the on and off state of the servo motor in our hopper.
This is the actual servo motor on top, which is a Parker SM232AE, and it's hooked up to our drive down below. We also have our Ethernet switch mounted on top, which just lets us have all our Ethernet devices, being our PLC, our HMI, and our Cognix, all hooked up through the same link. Here is our feed throat and also our sensor that we ended up using to be able to tell the PLC when there's a gumball present in the feed throat. It's a Banner fiber optic through beam. We ended up drilling a hole through our PVC so that that sensor could actually make contact and complete a beam when there's not a gumball present.
Alright, here you can see our Cognix vision system. It's a Cognix Insight 7100C. It's a color detection model. We are using the camera to detect what color gumball that is present in front of it. Every time a gumball drops down, the sensor triggers our logic to acquire an image inside the Cognix software, which is called Easy Builder. Inside of the software, we teach the Cognix what each color is. It doesn't know the difference out of the box, so you have to teach it the 4 different colors. And then depending on if it's a valid color that it knows or not, we use PLC logic to control the rest of the system.
Now here's going to be a quick video demonstration of our gumball machine. Here you can see our servo motor actually turning through the hopper. One of our gumballs is going to fall through. We were looking for a red. There you just saw the Cognix take the picture and then the diverter moved over. Here we're still looking for a red one, but we're going to see a white one drop down. The camera triggers. Since the diverter is already in the correct position, it doesn't need to move. The gumball drops down and our return cylinder pops it back up into the hopper.